Hello, all the crazy people out there. My name is Michael. I like wizards and dragons and making games, and welcome back to discussions of Autotiles in Game Maker. So, in the first video on Autotiles in Game Maker that I made, we set up a very simple 16-tile autotile system, which is going to iterate over a grid of basically tile states on or off booleans. And for each tile in the tile map, it's going to check the state of each of its neighbors to the immediate north, south, east, or west, and it's going to use that information to figure out which tile index each individual tile should actually have. So center tiles have no connections to the outside world. Tiles that are on a bottom border have a horizontal border pattern. Tiles on a corner have a corner border pattern. And this was quite simple. It works pretty well. This is probably the autotile system that most people came up with the first time they ever tried implementing autotiles just in general on their own. But there are others, and I would like to discuss several other systems of autotiles that you can do in a game in this video and also in future videos. So, the autotile system that the Game Maker room editor uses is actually different from the autotile system that we discussed in the previous video. And if you haven't seen the previous video that I made on autotiles in Game Maker, you probably are going to want to do that. I am going to call back to it a couple of times in this video, assuming that people know what's going on there. And also, specifically, we're going to discuss bitwise logic in as like a computer science concept, and we're going to make some use of that in this video, the same way that we did in the last one. So if you don't know how bitwise logic works, I also have a video on that you might want to go and watch. Anyway, so the Game Maker autotile system, if you go and actually look at the autotile pattern that Game Maker will give you if you try to use Game Maker's autotile system, you'll note that it's actually not the same pattern as the one that we set up in the previous video. And the reason for that is that these two autotile patterns are trying to do slightly different things. If you go to the Game Maker room editor, and if you're to go and grab an autotile brush, you will notice that you are always going to place tiles down in a 3x3 block. You'll never be placing individual individual single tiles. And as such, this autotile pattern the Game Maker contains doesn't have things like like an island piece, or I guess what you can call a peninsula piece that's only has one neighbor to one side. Instead, it's got corners, it's got straights, it's got diagonals, and it's got some other things that our system from last time didn't account for. And depending on what exactly you're trying to accomplish with your autotile system, you might prefer one or the other of these two autotile strategies. So, let's see. I'm going to just go and play around a little bit with this in the Game Maker room editor because I think it's fun to do that, and I never miss an opportunity to play around with the Game Maker autotile system just in general if the opportunity presents itself. This is not a unique feature to Game Maker. A lot of other game engines do have stuff like this built in at this point, but I'm going to enjoy it while it's here. Let's go and turn that off because we don't actually need to see that when we're running the game. In the sample project over here, I have gone and made a couple of changes. I've taken the code that we wrote last week and I've just dumped it in its own function. And it's going to return the tile info ds grid, and it's going to take the template as a parameter. And I've also gone and taken the code to actually populate a tile map from that tile info, and I've made that its own function as well. Just because I think that's good organization, and I'm going to like do something else in this video, but I don't want to delete or comment out the original code. I'm also going to do something in this video that I probably should have thought to do in the last video, and that is going to be to actually manipulate this on the fly. I think that'll be quite a bit of fun. We'll do that towards the end. And one last thing before we start. This algorithm that we're going to use in this video is going to kind of be of my own invention. I found out after I did this that Game Maker is most likely using marching squares to do this, which is, I'll just say straight off the bat, it's much more computationally efficient. But I do think that the version that I came up with is easier to explain, so I'm going to be sticking with my kind of hacked together way of doing autotiles in this video, and I'm sure at some point in the probably not so distant future I am going to be talking about marching squares because I can never leave well enough alone when it comes to doing fun computer science stuff. So let's go and actually get started here. I'm going to go and make myself a script. I'm going to call it autotile 16. Let's call it autotile 16 corners. And the reason that I'm going to call it that should become apparent fairly soon. I'm going to take the autotile template and I'm going to pass that in as a parameter. And I think I'm also just going to borrow some of the initial setup code that we did in the previous video. So getting the width, getting the height, creating the tile info grid, clearing that to a value of 0. I think I said this in the last video. I'm pretty sure when you create a DS grid in GameMaker, it will automatically be initialized to 0. So this line here is kind of like not necessary. But just in case I am misremembering, I'm going to do it anyway. And let's actually start writing some code. So the way that I'm going to do this is... Again, it's not going to be the most efficient way of doing autotiles. I am going to do this in 2 passes. The first pass that I'm going to do over every tile in the tile map is going to just simply be to figure out if each tile is surrounded completely on all 8 sides by neighbors. And the way that we're going to do that is that we're just going to go for each tile in the tile set, in the tile map. We're going to check its neighbors to the northwest, north, northeast, west, east, southwest, south, and southeast. And we're going to see if there's something exists there. And if there is something on in all 8 of those directions, we're going to say the tile is surrounded. If there is not, we're going to say the tile is not completely surrounded. And to do that, we can begin with a good old friend, the double for loop. So var I equals 0, I is less than width, I plus plus, for var j equals 0, j is less than height, j plus plus. And now we're going to need to iterate over each of the neighbors, and we're going to do that by doing another double for loop, which is going to sound bad. And, well, it's definitely not great, but it's also going to be a 2 loops of a fixed size. Let's say var k equals -1, k is less than or equal to +1, k plus plus, and do I really want to use L for var L equals -1, L is less than or equal to +1, L plus plus? I don't really want to use L because L looks a little bit too much like the numeral 1. So I think what I'll do instead is I'll make that capital L instead of lowercase l, which is a bit of a break from the naming convention, but at least it doesn't look like the numeral 1. And to figure out if a tile is surrounded, I'm going to start by assuming that it is, and I'm going to try to disprove it by checking each tile, and if I find one example where a tile is not surrounded, then that means that we can just stop looking there, and we can just prove that the tile is not surrounded. So as we did in the last video, if tile gets empty, tile map gets, the tile map is going to be the template. The X cell is going to be I plus K. The Y cell is going to be J plus capital L. If that tile is empty, then I can say surrounded equals false. And at this point, like, this is all the information we need. We can break out of the loop. And if you'd like, we can say if surrounded, break out of the outer loop. That's it. That's our result. Or we can do what I probably should have done just in general the first time, and we can make this a function, and we can take advantage of the return statement as a bit of a control flow. And I can say var, let's call it get tile surrounded. Tile map, I'm going to want an X cell and a Y cell. And that needs to equal a function which takes those arguments. Real fast, one of the random annoying things about GameMaker is that you can't create a local variable X or Y. If you try to do this, the compiler will yell at you, because X and Y are, like, reserved instance variables. But you can do it, you can create them as function arguments. You can say X and Y are function arguments. I don't know why Yo-Yo Games made that design decision. It's really weird. Function arguments are, for all practical purposes, just special local variables. You can treat them, you can even reassign values to them and everything. It's just you can't define them with var. And it's been like that since the dawn of time. I don't know if that's just like legacy GameMaker behavior that nobody ever thought to like change, or if there's actually a reason for it. Anyway, let's go and take all this, and we can... I'm going to have to update some variable names. So the tile map like this has a new variable name. Instead of saying I and J, I can say X and Y. And instead of defining a result variable that's surrounded equals true, I can just skip that. And if I find a counterexample, I can say return false. And if you never return false inside this double for loop, we can return true. And at this point, we're pretty confident that like, if you get to the end of this double for loop, then the tile is surrounded. And I can say in here, var surrounded equals get tile surrounded. We need to give it the tile map template. The X is going to be I, the Y is going to be J, and we can be on our way. So, before I do anything else, I'm just going to go and do a little bit of a debug visualization, and I'm going to feed the result of this into the tile info, like that. And this is just going to draw 1 if the tile is surrounded, and it's going to draw 0 if the tile is not surrounded. And we can do this to check if I'm not actually calling this code. Let's call this code. Control D duplicate will duplicate a line. Let's swap in autotile 16 corners there. And let's go and have a look. So indeed, I see the tiles that are completely surrounded on all 8 sides they have a 1. The tiles that have an absent piece on 1 or more of those sides have a 0. All right, that's our first pass. So before I move on to the second pass, I'm going to set something else up, and that is going to be to basically define each of the bitwise patterns that we're going to be using. So in our original 16-tile autotile code, I just kind of hard-coded in the bit patterns, and like if you find a tile to the north, then you're going to say mask bitwise or equals 0b0001. I am not going to do that. I'm actually going to like name these by like setting them to variables. And that's because in the way that I've implemented it here, I'm going to have to actually use these values for a couple different things. So firstly, there's going to be 8 of them instead of 4, and I'm going to call them mask northwest equals 0b 0000 underscore 0001. For those of you who've never seen this before, the underscore is not actually part of the number. That is just a visual spacer in case your eyes start to cross looking at a bunch of zeros and ones. I'm going to duplicate this a couple times. North is going to be 0010. Northeast is going to be the next bit. Next, west is going to be the 4th bit. East, that is going to be the 5th bit. Southwest is going to be the 6th bit. South is going to be the 7th bit. And southeast is going to be the 8th bit. So we have 8 numbers here. If you want to do a sanity check, northwest, north, northeast, west, east, southwest, south, southeast, that is going to follow the same like direction as this double for loop will here, basically scanning across each row and column. There is no center tile. We're not going to define a mask pattern for that. And the actual bits themselves just go in ascending order: the 1st bit, the 2nd bit, decimal 4, decimal 8, decimal 16, decimal 32, and so on and so forth. And the second thing I'm going to do is I'm going to define an array, and this is going to be, I'm going to call it mask order. And this is going to be an array of kind of like just a bunch of magic numbers. And if you want to copy and paste this, I will not blame you, but let's just go and get this over with. Mask south, bitwise or mask east. I'll explain what this all is for in a minute. Mask south, bitwise or mask west, mask south, mask north, bitwise or mask east, mask east, northwest or southeast, southeast, mask west or north, other way around, doesn't matter, these operations are commutative. Mask northeast or mask southwest, mask west, mask southwest, mask north, mask northeast, and mask northwest. So this should be 14 values, I think. Let's count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. If you want to copy and paste this, I will not blame you. This looks completely arbitrary. It doesn't really look like there's a rhyme or reason to the order that these are defined in, but using this specific order, if you were to do a second pass over the tile map, if you were to iterate over it, if you were to figure out which tiles are surrounding, build a mask from that, and then scan down this array in order, you would be able to sort of do a process of elimination to figure out which like which index in the autotile array should correspond to a tile. So let's get on with that second pass, and I can just copy and paste my double for loop here because I'm getting tired of writing it out. Let's see, I feel like I should assign this to a keyboard macro, or like, does GameMaker Code Editor 2 support snippets yet? It doesn't look like it does. I thought it did. Why would you want to sort lines alphanumerically? This makes me think of, like, have you ever seen someone, like, taking the entire words in, like, The Lord of the Rings or whatever, and then sorting them in alphabetical order, and then just, like, printing that out? That's kind of what this reminds me of. Where was I? So, we're going to iterate over the tile map a second time, and we're going to figure out, based on the status of the surrounded, and I'm going to need a, there was one thing that I forgot to do earlier. I'm going to need a second DS grid of our tile surrounded, let's call it, equals DS grid create, width, and height. Again, DS grid clear. I'm going to clear that to false. I don't think I need to, but just in case there is some reason why the DS grid wouldn't be initialized to a bunch of zeros, then we're going to initialize that to false anyway. And I'm going to store the result of this surrounded calculation in that DS grid instead of feeding it back into the tile output. And because I don't actually need this DS grid after this function is finished, we can just destroy that. You could also cache this somewhere if you'd like, if you think that would make your life easier. Alright, so when we iterate over the tile map the second time, we are going to do some different things based on the surrounded status of each tile. So, the first thing I think I'm going to do is I'm going to check if the tile that we're looking at itself is completely surrounded, and if it is, so I can say if tile surrounded index I, j. This is going to be kind of a special case, an early out case, as it were. I'm going to say tile info index I, j is going to equal 1. And if the tile that we're iterating over currently is not completely surrounded in and of itself, we're actually going to have to do a little bit of work to figure out what its neighbors are and to figure out what pattern it should be. If I were to run this now, just to do a quick check to see if we didn't do anything horribly wrong. This should put a filled tile in the middle of this autotile template. Very good. And now we just have the task of figuring out exactly what's going to happen around the boundaries. Let's see. Else, if the tile is not surrounded, we're going to start to do the thing where we build a mask. Let's say var tile mask equals 0. And we can start to build this mask based on the status of the tile surroundings. Except instead of actually directly checking if there's a tile, if there's a neighboring tile, we're going to check for each tile that is not surrounded. We're going to check for tiles that are surrounded. And the way that we're going to do that is going to be if tile surrounded index I minus 1 index j minus 1. So if there is a surrounded tile to the northeast, tile mask bitwise or equals mask northwest. Sorry, northwest, not northeast. I can say if there is a tile surrounded to the I and j minus 1, tile mask bitwise or equals north. If there is a tile surrounded to I plus 1, j minus 1, that is going to be northeast. And we can continue filling in this pattern. I minus 1, j nothing. I'm going to try and keep these lines approximately the same size because it's visually appealing that way. I plus 1j is going to be east, and I minus 1, I plus 1, going with j plus 1 is going to be the south tiles. And once we've built our mask, and this is kind of the same thing that we're doing in the tile is surrounded function, except instead of putting it in a loop, I'm just writing it out, like, the long way. And I suppose if you wanted to, you could, like, index mask underscore northwest, mask underscore north, and you could loop over this all the same, but I don't think it's that big of a deal. Instead, what I'm going to do is I'm going to loop over var k equals 0, k is less than array length mask order k plus plus. We're going to loop over the mask order array, and we're going to check at each position in the mask order array if the tile mask is included in the value at that index. So some of you may have noticed that these are a series of 8 numbers. There are 256 combinations of bit patterns that it's possible to have. But for checking the borders in this autotile system, a lot of those are kind of going to be redundant or otherwise not really making sense. And you can reduce this down to 16 different autotile patterns. So if I were to go and say if tile mask bitwise and mask order index k equals mask order index k. So if the tile mask is included in, or I should say, if the mask at each index is included in the tile mask, the other way around, then I'm going to say tile info index I j equals k, and we're going to break. We're going to stop looking. We don't need to search any further. I will want in fact, +2 on the end of this k, which is not something you see every day. The reason for that is that we kind of have a double off by 1. So for 1, Game Maker's tile set system has the index 0 in the tile set is the designated null tile, so we need to account for that. And also, because there's an additional off by 1 because I have my special case for tiles that are completely surrounded. I'm going to hardcode that to index 1, and index 2 in the tile set is actually going to be like the actual first tile. So I'm going to have to add 2 onto the end of that. And I think this should be about done. I don't think there's anything else I need to do here. I am going to want to go and... Oh, I did already, right, because I ran it halfway through. If I do this, and if I hit the spacebar, we can see that we have our corner piece, our corner 16 tile auto tile set, nice and neatly filling the space. So that's nice. You can look at the exact tile indices, which are not, in this case, binary masks, but they are indices in this mask order array, sort of. Or they are a result of the mask order array. And, like, I guess if you wanted to get rid of the +2, you could insert 2 zeros here, and you could do, like, k equals 2 as your starting condition. It really want to know what the keyboard shortcut to go to the beginning of the file is, because I constantly do it by accident, and I have no idea what it is and how I can turn it off. Anyway, if you padded out the array, you could say, like, var k equals 2, k is less than that, and then you could skip the +2 here. It's 6 of one, half dozen of the other. Anyway, so there are some limitations of this. So because this type of auto tile is meant to work with tiles being placed in a 3x3 block, I'm going to want to grab this. If I were to place an individual tile like this, or if I were to place a block of 2x2, or maybe 1x2 or 2x1 tiles, these tiles will just be ignored because they are not adjacent to a interior to a surrounded tile. And again, some of these patterns don't even make sense in this tile set. Like, there just isn't a tile for an island piece like this, or 2 peninsula pieces like this. And I suppose you could write some special code to handle cases like this, like the 2x2, which you theoretically could assemble from this tile set, but I think that's a little bit beyond the scope of what this is intended to be used for. However, what this is intended to be used for, like I alluded to at the beginning, if you wanted to see this working in real time, let me just write a little bit of code, and I'm going to let's say var xcell equals mouse x div32 var y cell. Actually, you know, before I do this, let's go and commit our changes. 16 auto tiles with corners. Alright, now I can say xcell equals mouse underscore x div32, y cell equals mouse underscore y div32. Let me go and draw a rectangle. Xcell -1 times 32, y cell -1 times 32, and it's going to extend to xcell +2 times 32 because I want to go to the boundary of the cell. Y cell +2 times 32, and outline only is going to be true. I do actually want the outline only in this case. And when I do this, this should just draw a nice rectangle in a 3x3 around my mouse cursor. All right, that's great. And I'm going to say next if mouse check button mb underscore left. I'm going to take the tile template and I'm gonna set some tiles in the tile template in the 3x3 around the mouse cursor. And I'm going to do that by saying for var I equals -1, I is less than or equal to 1, I plus plus. We've seen this several times now. For var j equals -1. Let's just say var tile here equals tile map get. The tile map template. Xcel is going to be xcel minus I plus I. Ycel is going to be ycel plus j. We can set the tile index by saying tile here equals tile set index. Tile here. I'm just going to set it to 1 because in our template tile set, index 1 is the enabled tile. And tile map set tile map template. And we're just going to use these coordinates from before. Why did you not like that? I also need to set the... what argument is that? That's the second argument. I also need to actually specify the tile data that we set. Alright, so now if I do this, our template should update when I click. Yeah, but the tile map has been baked, set in stone at the beginning on game start, so it's not going to be updated. However, if I want that to be updated, I'm going to dsgrid destroy tile info because we will be regenerating that. Tile info equals autotile 16 corners set from the template. And I will not destroy the tile map generated, but I will autotile set tile map. Is that not what I called it? Autotile 2 tile map. And we can basically reset all the tiles in the generated tile map like that. So if I run the game now, and if I hold spacebar, if I paint down tiles, we will now be able to see all the tiles are stitching themselves together in real time. Good fun. One thing you might notice, and it works for the diagonals too, which is nice. One thing you might notice is that when I did that, we got a bunch of printouts in the console saying grid index out of bounds, and that is because the DS grid, the DS grid indices that are on the boundaries of the room, you're gonna end up checking like negative indices or out of bounds DS grid indices, and Game Maker will generally like give you the stink eye when you do that and move on. But you might want to be a little bit careful with the boundary tiles so that you don't pick up out of bounds errors. If you have GML release mode enabled, then this will simply like crash your game without an error message because of the out of bounds. You did not like that for other reasons. Why did you not? That feels like a bug. That should like actually just crash your game because release mode is supposed to... I don't know what that's about. Anyway.
Hey.
So I'm not going to insert bounds checking in here. You can do that yourself if you'd like. That is otherwise pretty much it for this algorithm for figuring out 16 tile corner oriented auto tiles. Again, I would probably like to make a video on doing this with marching squares eventually. Doing that would be somewhat less code and considerably more efficient. Like, if you were to time the amount of time that this code took, even without the DS grid out of bounds nonsense, doing this with marching squares will just be, like, less code. So it should be a little bit faster. But that's gonna have to wait for another day. In the meantime, my name is Michael. I like wizards and dragons and making games. If you want the code for this, look for the GitHub repository down in the description of this video. I like to make videos on all kinds of stuff you can do in Game Maker, so if anything like this appeals to you, feel free to subscribe. I like to make videos on both beginner stuff and also more involved, complicated stuff like this. I have a Patreon, so if you'd like to contribute to the channel, links to that can be found in all the usual places. And if you felt like pledging, I definitely would appreciate it. You should all go check out Wizarducks and the Lost Hat, which is one of the games that I like to work on when I'm not doing YouTube stuff. Link to that Steam page can be found down below as well. I hope you all found that useful, and I will see you all later. Special thanks to Zenjamin, Zach Robinson, Squarecrow, Spy Games, Pixelated Pope, Paradox, Nykotic, Manta Ray, Game Maker, Gameart Indie, Edward Holt, DJ Gibbles, Bokeh Dev, and Argo the Knot for supporting these videos. If you want to join their ranks and contribute to the channel, head on over to the Patreon page down in the video description to join the fun.